Hello and welcome back to our series on statistics. My name is Manny and we're coming to you from our downtown offices. Let's begin. This is presentation 1.3, part of a multi-part series in Statistics 101, and we acknowledge the people designated here as part of this presentation. Now just a quick review. We have here the notion of a population, and the red arrows denote a random sample of items from the population constituting our random sample down here. Parameter, any characteristic of the population, and the symbols are population mean mu, standard deviation, and proportion as designated here. Statistic is associated with a sample, and it's a characteristic of the sample data, and the symbols are coming on here. And the arrows mean we use these sample statistics to make inferences about the population on the basis of our sample data. Now the first method of sampling is called random sampling, and it involves a method whereby each and every item of the population has the same chance of being selected. And of course the best way to do that is to assign a number to each and every item of the population, and then using a software package to generate 100 or so, several hundred items from the population. And we have here a number generated randomly, and finding the item of the population corresponding to this item, and these constitute our sample, as you can see them coming on the screen here. And we designate these sample items as x1, x2, x3, the x denoting a variable and the subscript denoting the number of that item that's selected. This involves what's called a pseudo-random number generation, and no human involvement should be involved in this process. In other words, no bias involved. The second method is called the simple random sampling, and it involves a scheme whereby each and every sample of size n has the same chance of being selected as any other sample of that same size. And of course we have here the notion of these are pills and a pharmaceutical, putting in a scoop and scooping up a sample from the population. Now this is assumed to be randomly distributed, in other words thoroughly mixed. And another example of course is the grain from a large bin, and you can see here the third is a deck of cards where you randomly select 5 cards and so on. The third method is called systematic sampling, and a typical example is a listing or on an assembly line here. We randomly select the first item through a die, for example, and then we select every 12th item following that. And we have them coming on the screen here. And the problem with this, there may be a potential systematic error, every 12th item perhaps being defective because of the mechanism involved, such as wheels or cogs or whatever. The fourth one is called stratified sampling. The population is divided into mutually exclusive subgroups, ideally all of the same size, and we have what are called strata. An example is strata might be gender, male, female, age groupings under 25, 25, 50, above 50, and we're interested here in the attitude of the various individuals in the groups to see if there's a pattern here. Geographical regions, educational levels. In particular, we want to see if the education level is a factor of an attitude or an opinion. And at the bottom here we have a geographical stratified sampling. We have the cities involved here, and we're suggesting that to do this appropriately we need to use proportional sampling, and that is to say we have a population size of 110,000. We wish a sample size of 550. We take that ratio, which is 0.5% of the strata here. So we take 0.5% of 90,000 and so on, and we have here a proportional sample. In this respect, the notion of each individual having the same chance or probability of being selected as any other. The next method is called cluster, and this involves the population being divided into non-overlapping clusters, ideally all the same size or similar size, and then we take a random sample of clusters. And on the board here we have, this may be a geographical region, the southern slopes of the southern Alberta, for example, and we have this grid, and we take a random sample of items from the grid, more or less number-wise, and then we come up with a sample of clusters. We go into each of these clusters and count the number of trees infested with the pine beetle, and then average them over, and that gives us an idea of cluster sampling. Now the next is called convenience or volunteer sampling, and this is perhaps the worst possible scenario for a random sample. As a matter of fact, it's not random. It's done at one's convenience. And typically, after an aircraft flight, individuals are asked to fill out a questionnaire that's placed on their seat. And of course, one would fill this out if you have some sort of complaint, thereby creating quite a bias. An example, if you go to a bar and you ask some friends their attitude toward drinking, of course you're going to get a biased sample because of the idea of drinking at a bar and so on. And finally, look at the following here. Now we're going to put these on the screen here and ask you to identify the type of sampling involved. So pause the screen now and see if you can answer these. We're going to put the answers on the screen now, and here they are. So now write this down. This is part of the, you'll be tested on this. And that's the end of presentation 1 we ask you to review once again, take notes as required, and go to presentation 104.